Welcome, my friends. So far in our study of trigonometry, we have used the degree as our measurement of an angle. In this video, we will introduce a new unit of measurement for angles, which is the radian. Consider a circle that has the center here in the middle. So you should hopefully know that if you draw a line segment from the center of the circle to any point on the circle, such as this, then the distance of that line segment would be the radius, which we represent by r. And it doesn't matter which point I choose on the circle, so maybe I could choose another point over here, and that distance would still be the radius. So the distance from the center of the circle to any point on the circle is what we call the radius. And if we draw one radius and then another radius somewhere else, depending on where those 2 points are on the circle, that will create some angle between them, and we're going to call that angle theta. Now, of course, if I change those 2 points on the circle, then that would change the angle theta. So maybe I change this point here, then the angle theta between those two kind of line segments would be a different angle. Okay, and also depending on where you've chosen those 2 points, there will be a different distance along the circumference of the circle. So you can think of from right here all the way up here, you could measure that distance, and that distance is also going to change based on where you've chosen those 2 points. And so this is the distance I'm talking about. You may be familiar with this term. It is what we call arc length. So arc length is the distance from one point on the circle to another point on the circle, usually measured counterclockwise. Okay, and depending on where we choose the 2 points on the circle, that will change both the angle as well as the arc length. So maybe I choose another point over here, and the arc length is going to be quite a bit larger in that case. Okay, now here's the important thing, how we tie this into our new measurement of an angle. There is some angle that we could have such that the arc length would be equal to the radius. So let me show you what I mean by that. So if we choose this point right here, then it just so happens that the arc length, which is this length right here, actually is exactly the same length as the radius, okay? So if we choose 2 points on the circle such that the arc length is equal to the radius, that's going to create some angle. And that angle has a special name. It is what we call 1 radian. Okay, so 1 radian is the measurement of an angle where the arc length is equal to the radius, right? So we have 2 points on the circle, and the distance between those 2 points is the radius, or the distance along the circumference of the circle is the radius. And if that is the case, then the angle between those 2 points is what we call 1 radian. How big is 1 radian? Well, in degrees, 1 radian is approximately 57.3 degrees. Now, you probably already know this, but all the way around the entire circle, that is 360 degrees. So how big is this in radians? Well, if you were to measure not in degrees, but in radians, then this would be 2 pi radians. So all the way around the circle is going to be 2 pi radians. Or if you want to go like maybe halfway around the circle, it would only be pi radians. So this ends up being very, very convenient for us because we typically are going to be able to express radians in terms of pi. So perhaps you have pi radians, that would be halfway around the circle, so that would be half of the circle. Or pi over 2, that would actually be just a quarter of the circle, right? So typically when you see radians expressed, they won't be expressed like 1 radian, 2 radians, 3 radians. Typically they're going to be expressed in terms of some fraction of pi. Radians turn out to be a much more common form to measure an angle in trigonometry. When you go on to calculus, you basically never use degrees anymore. Almost everything is done in radians. Also, there are many formulas that don't even work in degrees, so you must get familiar with using radians. Oftentimes, you might want to convert between radians to degrees or vice versa. I'm going to show you how to do that next. Let's say that we already have radians and we would like to convert to degrees. Let's start with a known equality. We know that 2 pi radians is equal to 360 degrees. Both of these quantities represent 1 revolution of the circle. So if we want to convert to degrees, we'll have to solve for radians. So let's divide both sides by 2 pi. The 2 pi's will cancel here, and then 360 divided by 2 is 180. So we will get that 1 radian is equal to 180 degrees divided by pi. So that means to convert from radians to degrees, all you have to do is multiply by 180 and divide by pi. We can also do it the other way around. So if we want to go from degrees to radians, then we would have to solve this for degrees. So let's divide by 360. We want to solve for 1 degree, basically, so we can divide both sides by 360. Again, over here, we'll have 2 over 360. We're going to get another 180 in the formula. It'll be in the denominator. You're going to get 1 degree over here. So 1 degree is equal to pi over 180 radians. So that means in order to convert from degrees to radians, multiply by pi divided by 180. Now, what's an easy way to remember these formulas? Notice that they both have 180 and pi in them. For here, we have 180 divided by pi, and here we have pi divided by 180. So how do you know which one is which? Well, if you want to go to degrees, that means you're coming from radians. And as I mentioned before, radians typically are expressed in terms of pi. But degrees are not expressed in terms of pi, right? So that means you want to get rid of the pi. Dividing by pi typically means you're going to be canceling some sort of pi in your original expression, right? So if we divide by pi, that's going to get rid of the pi and it's going to leave us with something in terms of degrees, right? So that can maybe help you remember, if you want degrees, you're probably going to be dividing out the pi. If you're going the other way around, if you're trying to convert to radians, then you have to introduce pi because radians are typically expressed in terms of pi. So multiplying by pi is going to introduce pi into the expression, and then we will have radians in terms of pi. So that is one way you can perhaps remember these formulas. Let's take a look at some examples. So we are asked to convert pi over 2 radians to degrees. So I always remember that if I want degrees and I already have radians, that means I need to cancel the pi. So I'm going to be multiplying by 180 divided by pi. Dividing by pi is going to cancel the pi in my original expression here. Okay, so I will have pi over 2 times 180 over pi. The pi's will cancel, and I can reduce 180 divided by 2. That is the same thing as 90. So therefore, pi over 2 radians is the same thing as 90 degrees. On a circle, we typically measure this from the positive kind of x-axis over here up to another point, and this would be a 90-degree angle as shown on the circle. Okay, let's try another one. So let's convert 7 pi over 6 radians to degrees. If we've already got radians and we want degrees, we're going to have to divide by pi, but we also have that multiplying by 180 in the numerator. So let's multiply by 180 over pi. The pi's, again, are going to cancel. And then 180 divided by 6, that can be reduced to 30. So we basically just have 7 times 30. That would equal 210 degrees. So if we wanted to think about that on a circle, that would look something like this, right? 210 degrees would be, well, 180 degrees would be right here, half the circle. So we're a little bit past that. Or maybe think of this as 7 pi over 6. 6 pi over 6 would just be pi, and pi is half the circle. So this is 6 pi over 6, but we're a little bit further, another pi over 6 further, and we would be down here 210 degrees or 7 pi over 6. All right, let's try another problem similar to this. We are asked to convert negative 0.3 radians to degrees. Now you might be looking at this and wondering, what does it mean to have a negative angle? A negative angle just means that we are measuring clockwise rather than counterclockwise on the circle. So we are measuring down rather than going up. You're still going to use the same formula. There's not going to be any pi to cancel, so we're still going to have pi in our final answer, but that's all right. So if we take negative 0.3 and we multiply by 180 divided by pi, and if you type that into your calculator, you should get about negative 17.19 degrees. So negative 17.19 degrees is the same thing as negative 0.3 radians, which we can see here on the circle. Let's look at some problems going the other way around, converting from degrees to radians. So if we want to convert 45 degrees to radians, the first thing I remember is that radians typically include pi, or expressed in terms of pi. So we're going to want to introduce pi into our expression. So we multiply by pi. And then we can't forget to divide by 180. So 45 multiplied by pi over 180. 45 over 180 can be reduced to 1 over 4. So we just have pi over 4. So 45 degrees is the same thing as pi over 4 radians. And this is the way that would look on the circle. So pi over 4, this is a 45-degree angle. From these 2 points, we have an angle of pi over 4. How about negative 120 degrees? We'll do the same thing. We will introduce pi by multiplying by pi and then divide by 180. So if we do that, we can reduce a little bit here. 120 divided by 180, that could be reduced to 2 over 3. So we just have, we still have this negative sign out here, so we'll have negative 2 pi over 3. Remember that negative angles are measured clockwise. So this is going to look something like this. So negative 2 pi over 3 is moving clockwise, and we would be all the way here, and this would be our angle. You can kind of think of the bottom half of the circle as negative pi. So going all the way over here would be negative pi or negative 3 pi over 3, but we're only at negative 2 pi over 3. So you can think of the bottom half as split into 3/3. This would be about 1 pi over 3. This is 2 pi over 3, and then this would be 3 pi over 3. Okay, let's try one more. Convert 312.75 degrees to radians. So multiply by pi and divide by 180. And we will get about, if we type that into our calculator, 5.46 radians. We can't really reduce anything here. Okay, so this is a relatively large angle, 312.75 degrees. This is going to be most of the way around the circle. It's going to be all the way around here. This is the angle shown here, and that is 5.46 radians. All right, my friends, that completes this video relating to converting from degrees to radians and vice versa, and I guess in general introducing radians.